So, good morning, dear friends. This is Professor a.k.chaubey in the Professor Chaubey Physics class under the heading Physics Made Simplest. So, we will be now talking today about alternating current, alternating potentials, and circuits using alternating potentials. Then RL circuits, RC circuits using alternating potentials. So we will talk about so you can say alternating So as we know, alternating current, or we write in the short AC. AC means it is not direct current, means it is not one directional current. It is not a unidirectional current. And it is not a constant current. It is a varying current. Varying current can be direct also in one direction. It is fluctuating. But it is varying current means its direction changes. Its the direction is positive and sometimes negative. It has got certain frequency. Means we can write like current like I is equal to I naught sine omega t. For the EMF of potential E is equal to E naught sine omega t. Well, it can be cos omega t also, because you know sine, cosine, same thing, difference of some phase angle. So it can be, we can write I is equal to I naught cos omega t also, no problem. So this is, if this is the EMF, means omega is angular frequency. You know omega is 2 pi f, or it is 2 pi over t, where f is the frequency, t is the time period. And you know we represent the current I simply on the time scale. This is the time scale. This is the say current scale I. So this current like this. So this is say time starting 0. This is a half time period. This is t by 2 and this is the t. And remember that you can get the angle here. They start, so this is the complete angle 2 pi. The angle here is pi by 2. Angle here is pi. Here 3 pi by 2. And here is a 2 pi. So 2 pi means one complete cycle. And this is represented also in terms of a phasor diagram, like say you have say circle. Yes. So on terms of a circle, say the diameter of circle here, and we have a vector, this O is here, and this vector OA. Then OA, this angle theta. If the angle is 0 here, this A is here, it means it is starting here. When angle increases, it reaches say here, pi by 2. This pi by 2 means this position. 0 to pi 90 degree, pi by 2, this position. So this circular motion of this OA vector, that is, you can say any potential vector or current vector, the circular motion of this anti-clockwise, so theta increasing from 0, here it is 0, 0 and then pi by 2, and then here, you can say, and then going here, and then here, again coming here is 2 pi. So pi by 2, and then pi, and then 3 pi by 2, and then 2 pi. So this complete one rotation of this vector OA, circular motion, represents one cycle here. This is the positive half cycle, and there is a negative half cycle. So this means the current is represented by, say, I is equal to, this is the maximum current here. This is maximum means I naught. I naught is the amplitude. So I naught is the amplitude and omega is angular frequency, or F is the linear frequency. T is the time period, that's below. So alternating currents and alternating potentials are represented in this way, that for, say, 0 to pi, current is one direction, from pi to 2 pi, current is opposite direction. So that is the representation of alternating current or alternating potentials. Then we have, say, a mean value of, this was a, I naught is the peak value, I naught and E naught both. I naught is the current, E naught is the potential. Peak value of current and is the peak value of potential. Peak value of voltage. You can say mean value means mean over the full cycle. From here to here, you say current is one direction, current is reverse direction. So obviously, if this amplitude both are same, here also the I naught. Remember that the obvious mean value of the current, here it is increasing from 0 to maximum, then coming maximum to 0. Here 0 to maximum but negative side, maximum to 0, negative side. So this half cycle obviously, and this half cycle obviously, the area of these two are equal. So area of these two are equal means the total current here is positive, total current here is negative. So mean of this, you add this, becomes 0. So mean value of current over one cycle is 0. So obviously mean value is not measured because mean value is 0. Well, you can see this mean value also mathematically. Mathematically also you can find out the mean value on say, you can write say I is equal to I naught sine omega t. Say for a small time dt, a small current or a small charge flowing, dq for a small time is current flowing in time dt. So dq, dt is I. So dq can be written as I dt, charge dq. Or this is I is I naught sine omega t dt. And this you see dq for the whole cycle or half cycle we can take here. Q for say half cycle 0 t by 2. I dt means 0 to t by 2. I naught sine omega t dt. This means that you integrate this under the limit 0 to t by 2. That is for half cycle only. So what you will get? So you can write, you can integrate this, you will. This, you can write this. Q is equal to say I naught, and the sine omega integral of this is say cosine omega and t minus omega and the integration limit 0 to t by 2. So this is the integral of this, and or this is equal to I naught over omega, and you put the limit of time t by 2 and 0. So this becomes minus, of course, here, and then this inside becomes cos omega t is equal to t by 2, and t by 2, you know, t is equal to 2 pi upon omega here. So this becomes cosine pi minus cosine t is equal to 0, so 0. So this becomes cosine pi means minus 1, cosine 0 is equal to 1, minus, so minus 1 minus plus, so this becomes 0, and this is 2I naught, yeah, minus 1 means cosine 0 means 1, so minus 1 and minus 2, this minus means plus, so plus twice I naught over omega. So this is the Q is equal to twice I naught omega. Charge flown in this half cycle. Charge flown in the half cycle is 2 I naught over omega. Now, so you can say half cycle, if Im is the half cycle average, if Im is the half cycle average, then average value of AC mean value, only half cycle, then by definition Q is equal to 2 I naught over omega. So Im into t for half cycle, for time t by 2. This means from here to here, and then here full time. So for the half cycle in t by 2. So what the value Im is equal to, we have Im t by 2 average is 2I over omega. To I naught. So Im t by 2. So that means Im, the mean value, Im is equal to 2 to 4 I naught omega over t. So 2 I naught, omega is t is equal to 2 pi over omega. So this we can write. T is equal to 2 pi over omega. So Im is equal to 4 I naught, this t is equal to 2 pi over omega into omega. So omega cancels, this 2 pi 2. So Im is equal to, this omega cancels, 2 I naught over pi. And 2 I naught over pi. 2 over pi is 3.14. So 2 over 3.14, this is 0.6. Im is equal to 0.637 of I naught. Means mean value of the current for this half cycle is 0.637 I naught. And remember, this is plus value, one direction positive. Similarly, you can get for negative half cycle Im, mean value of Im will be equal to minus 0.637 I naught. So this is minus, for this is plus, same value, because a cycle is same, time period is same, maximum amplitude is same. So means average value of current for full cycle is 0, because half cycle plus half cycle minus. So this means average value of current is 0. So how to measure? You cannot measure the current in this way, because mean value is 0. So this is what we can say, we cannot measure mean value for one cycle as it is 0. So current is not measured as the Y using a mini ammeter or ammeter as the full cycle, as this becomes 0. Half cycle pointer goes positive, half cycle negative, so it is 0. So what is done is that current is measured in terms of in terms of some effect which is same for positive direction current and negative current. That is heating effect, because if you pass a current through a resistance wire or any wire which has some resistors, it will have heating effect, means temperature will increase. Whether current flowing from A to B or from B to A, heating effect is same. It will heat the wire, temperature will increase. Temperature will not go down, because current flowing means work is being done. So work is being done means there is power invested there and has energy generated, means temperature, heat energy. So heat energy is generated or temperature increase is same whether it current is say in positive direction or current is say in negative direction. So we measure current and EMF using hot wire ammeter or voltmeter. These are hot wire means current passes, the temperature increases. So the needle deflection depends upon the heating produced by the wire. So that is how the current is measured. And this current, we call this as say, current defined is say, one is root mean square. So this RMS, or it is called RMS value. RMS value of current or potential means now we cannot measure average because average is 0. So RMS means the value of current which produces same effect which is produced by the, say, direct current, means positive or negative. Both currents flowing through the wire producing same heat. So that much current which is producing same heating effect as a direct current. So the alternating current is that a steady current which when flowing through a given resistance for a given time produces the same amount of heat. So what we call the RMS value of current, that is AC, a same current which produces same heating effect which is produced by direct current. जो डायरेक्ट करंट जितना हीट प्रोड्यूस कर रही है उतना ही हीट एसी प्रोड्यूस करे, राइट, मतलब पॉजिटिव साइड में नेगेटिव साइड जाने में सेम अमाउंट ऑफ हीटिंग इफेक्ट, दैट करंट इज कॉल्ड आरएमएस फॉर एसी. सो रिमेंबर दैट this is I RMS or I effective also. So if it is I E double F, that is I effective. Or RMS bakka. So let the RMS, the current be represent AC current, A alternating current, AC bakka. AC represented as I is equal to I naught sine omega t, and then DI we have because we want know to heating effect. So what is the heating effect? Heat produced. DH for a small time is equal to, current, heat produced. Heat is Ri square, the energy, power. IR is the voltage drop, I square R is the voltage into current, V into C or V into I, that is the power. So DH, heat produced, is I square R, and in small time that is dt. Ri square is the heat produced, in small time dt. So that is equal to, say, I square means I naught sine omega t square and R dt. So this we can calculate, I naught square R, I naught square R, and sine omega square dt. So dH is equal to I naught square sine square omega t and R, I naught square sine omega t and R dt. So R, combine here I naught square r sine square omega t dt. So this is for time dt. H heat produced for say full cycle is 0 to t full time period dh. That you can integrate, so you can write 0 to t I square I naught square r. This is of course constant, you can take outside, and sine square omega t dt. So you integrate sine square omega t. We can write this as say I naught square r outside and then integrate this. So this integral 0 to t 0 to t sine square omega t means in terms of cos 2 omega t 1 minus cos 2 omega t cos 2 omega t upon 2 dt. Cos 2 omega t means cos square 2 cos square 2 omega t minus sine square. So that you have some relations. 1 minus sine square theta is cos square theta. Like that sine square, we replace sine square y from cos 2 omega t. Cos 2 omega t is this 1 minus cos 2 omega t upon 2 is sine square, because twice sine square omega t is 1 minus cos 2 omega t. So this you can use trigonometry relation, and then you integrate this, you will get h. H equal to, finally you integrate, put the limits, you will get finally h is equal to I naught square r, I naught square r t over 2. Just you put the, integrate this and put the limits. So you will get finally h is equal to I naught square r t over 2. So this gives you h, the heat produced in one cycle. Heat produced in one cycle, h is equal to I naught so this heat is produced by AC in full cycle that is from 0 to t, one time period. Same amount of heat is produced by DC, by say IV, that is average DC. Then you know that average DC, that is heat produced Ri square, time how much? T. IR square is the per unit time, because I is the current charge flowing in unit time. So S is equal to IV, average value of the DC, I square R, and time is T. And this here S is I naught square R T over 2. So what do you get? IV square R T, both heat are equal. I naught square R T by 2. So this R cancels, T cancels, and we get IB square is I naught square over 2. So what does it mean? IB, sorry. Yeah, some problem, what problem? Yes, IB is equal to I naught over under root T, do this under root 2. So this means that IB average current, DC current is I naught by root 2, means this is the peak value of the AC upon root 2, or 1 upon root 2 means 0.707, so this means 0.707 I naught. IB is equal to 0.707 I naught, 1 by root 2 I naught. And this IB is actually average value of DC, which is equal to the root mean square value of the AC current. So this means IB means for AC, it is the mean value and mean value IB. This is maximum and this is the root, under root. IB is under root of this. So I naught root mean square root of the square. So that is it can be shown that virtual or RMS value of an alternating quantity is given by, for IB means for AC, RMS value. Similarly, EB is equal to 0.707 of E naught, that is the maximum value of AC, peak value. So this EB and IB are RMS value in fact. These are the RMS value. Root mean square, because this means you square this and then this square this. So this is the root under root over 2 times. So this, similarly it can be shown that IB and EB both are 0.707 of maximum peak value, and these are called RMS values, root of mean squares. Means I1, I2, I3, different times current squares, you add them and take under root of that. Root of the mean squares. And current for full cycle like this, currents are different values here, peak values, and then square of that, root mean of squares. So root of, under root of squares value of current at different times for full cycle. So that is the RMS value of the current and the potential. So what our meter measures is not the peak value, not the average value, but RMS value means root of the mean squares. So this is the current and the potential which we measure. Now, what we want to do? So we can do some Okay. Okay. We do a problem to understand more. Say an alternating voltage of say 50 hertz, that is frequency 50 hertz, 50 cycles per second, has a maximum value of 200 under root 2 volts. This is the peak value. At what time measured from a positive maximum value positive maximum value, will the instantaneous voltage be 141.4 volts. This is the question. That is E is equal to E naught sin omega t is equal to E naught sin omega means 2 pi f t, and what they give value of voltage is 200 under root 2 volts. So this is the maximum value, 200 under root 2, and then sine 2 pi into t, 2 pi f, sine 2 pi f is 50 cycles, and t we don't know. So this is E is equal to 200 under root 2. You can put under root 2 1.414 and then multiply this. So this becomes 282.8 this, and sine 2 pi into 50 into t. So sine 2 pi 50 into 200, 3.14, so 340 sine 314 t. Now the equation is valid when time is measured from the instant the voltage is maximum. So the time is measured from the positive maximum value. Therefore, the equation will be, we can write considering that time is measured when the voltage is positive maximum, that is zero of time when the voltage is maximum, positive maximum. So we can write that means the phase difference, what is that? We can write, therefore, E is equal to E naught, this was the general equation. Now consider the phase, means at what time t is equal to 0. So that is to E is equal to E naught. Yeah, that same equation, that we repeat this equation. The voltage E is equal to 282.8 sin 340t, and this is E is equal to, this is the maximum, 282.8 is the maximum, sin 314t plus pi by 2, that is the phase angle. When zero time when the voltage is maximum, here means this, when maxima, so t is equal to 0 at this place. So that means phase angle is pi by 2. So maxima is here. So maximum we are measuring time, t is equal to 0. So means when the voltage or current is here, otherwise t is equal to 0 here. So this much is the phase difference. So pi by 2 phase introduced. So this is the equation. The voltage is given by maxima 282.8 sin 314t plus the phase angle. From here it starts. So this becomes sin this pi by 2 plus this means sin, so this same value. So E is equal to 282.8 and sin 90 plus theta is equal to cos theta. So cos 314 t, sin 90 plus theta is cos theta. So this is there. But the voltage is given as 141.4. This is 141.4. So you can now solve this, that cosine 314t is equal to 141.4 divided by 282.8. So this means this 1 by 2.5. Cosine 314t is equal to 0.5. So 314t is cos inverse 0.5. So cos inverse 0.5. How much radian? 1.047 radian. So T is equal to 1.047 divided by 314. That is equal to 3.33 into 10 to the power minus 3 second time. This means that 3.33, T is equal to 3.33 millisecond. 10 to the power minus 3 means. So this is the time. Then at this time, from the start, the voltage will be 141.4. Means starting from here, 3.33 millisecond, the voltage here comes down here maybe. So this may be the voltage, 141.4. And this is the time difference, is 3.33 milliseconds. This time difference, 3.33 milliseconds. Starting t is equal to 0. So like this, you should solve some problems. So this I have introduced today, AC and AC, how we can write AC. I will now explain phasor diagram, how we can represent the AC with complex numbers. And then next time we meet, we will do some resistance, inductance or resistance, capacitance, transient currents using AC voltages and AC current. So friends, thank you very much for listening.